Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to recognize roots of a quadratic equation as being the x-intercepts of the equations, and how to use the quadratic formula to determine the roots of a quadratic equation. How are we learning it? Through the finding roots by the quadratic formula part 1 notes and finding roots by the quadratic formula part 1 assignment. When can we use this information? To determine the distance of a home run in a Major League Baseball home run derby. How do we know we learned it? By getting a score of 4 on the finding roots by the quadratic formula part 1 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed the Get It Started, we'll go over it together and answer any questions that you may have. Next, we'll do the finding roots by the quadratic formula part 1 notes, and then I'll give you time to complete the finding roots by the quadratic formula part 1 assignment. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your before you go. Your only homework for tonight is to continue working on the quadratic study guide and any incomplete assignments that you may have. Let's take a look now at the finding roots by the quadratic formula part 1 notes. The notes begin with the learning goals and success criteria. Okay, what are roots? Roots of functions are the points on the graph of a function where the y values are 0. Another way to think of this is where the graph touches the x-axis. So we call these roots, we also call them sometimes roots, zeros, solutions, and x-intercepts. So all of those are different things that roots can be called in different ways. So what does a root look like? It's an x-intercept, or where the line crosses the x-axis. So it crosses here, and then it comes back down and crosses here. We call those the roots. So how do we find the roots of a quadratic? Well, the first step is factor the quadratic. So factor it any way you can, and then solve for the roots. So when we get here, we have x squared minus 5x plus 4. We would use our magic x, and once we do that, we should see that x minus 4 times x minus 1 is equal to 0. So we factor this out. Now we take each of those parts and set them equal to 0. So x minus 4 is equal to 0, and x minus 1 is equal to 0. Now we just solve for x. So we add 4 to both sides, and we get x equals 4. We add 1 to both sides, and we get x equals 1. So the zeros, or the roots, or the x-intercepts, whatever you want to call them, those ones for this equation are x equals 4 and x equals 1. Let's look at another example. We have x squared minus 5x is equal to 0. So again, we factor this, and we can pull an x out of this. So we get x times x minus 5 is equal to 0. Now we set each of those parts equal to 0, and that includes the x. So x can equal 0, and x minus 5 can equal 0. Well, x minus 0 just stays as is. It's just x equals 0. So that's one of the roots. The second one now, we add 5 to both sides, and we get x is equal to 5. So x equals 0 and x equals 5 are the roots for this quadratic. Now what about quadratics that can't be factored? So not everything comes out evenly. So not all quadratics can be factored. For instance, this one, x squared minus 5x plus 3 equals 0. This is a non-factorable quadratic. So when we get these non-factorable quadratics, we have to use what's called the quadratic formula. So what is the quadratic formula? Quadratics will always appear as ax squared plus bx plus c equals 0. And from that, we can create the quadratic formula, which says this: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's take a look at an example of how that works. First thing we need to know before we get started, though, is what is the discriminant? The discriminant is the part under the square root. If the value under the square root is positive, then we have 2 roots, and if the value under the square root symbol is negative, there are no roots. So that's why we call it the discriminant, because it discriminates here against negative roots. So if it ends up negative, then we know we don't have to do any other work. It's no solution. Okay, so let's take a look here. So we're given x squared minus 5x plus 3 is equal to 0. And we're asked to use the quadratic formula. So we're going to plug in. So negative b, so that becomes negative 5, which is positive 5. Plus or minus negative 5 squared minus 4 times a, which is 1, times c, which is 3, over 2 times a, which is 1. And we end up with this. So all I did was take and plug in to the formula. Now we can go ahead and start to work the problem. So negative 5 is just positive 5. Negative 5 squared is positive 25. And then negative 4 times 1 is negative 4 times 3 is negative 12. And then 2 times 1 is 2. So we end up with this. Now we just simplify under the radical. So 25 minus 12 is 13. So we get 5 plus or minus square root of 13 over 2. Now, notice there is no perfect square root of 13, so we just leave it as is. And we make this a plus, so this is 5 plus square root of 13 over 2. And then the minus part comes in, so this is 5 minus square root of 13 over 2. So anytime you see this plus or minus, that means we're going to do two things. We're going to add it and then subtract it. So we're going to do both to it. So here's our addition, here's our subtraction. These are our two roots. So we get another example. We have 2x squared minus 5x plus 3 is equal to 0. So we're going to plug it into the formula. So we plug negative 5 in for b. We plug, again, negative 5 in for b here. We plug 2 in for a, and we plug 3 in for c, and then we plug 2 in for a down at the bottom. We get this. We simplify. Negative 5 is just positive 5. Square root of 5 squared is 25. And then negative 4 times 2 is negative 8 times 3 is negative 24. And then 2 times 2 is 4. So we end up with 5 plus or minus 25 minus 24 over 4. Well, 25 minus 24 is 1. And then the square root of 1 is just 1. So now we end up with 5 plus or minus 1 over 4. So now we're going to go ahead and solve this. So this is 5 plus 1, which is 6, over 4. 6 over 4 is equal to 3 halves. And then we do it again. 5 minus 1 is 4 over 4, which is equal to 1. So our roots for this one would be 3 halves and 1. Let's look at one more example. We have 3x squared minus 5x plus 3 is equal to 0. So we plug everything in, and we end up with negative 5 plus or minus the square root of negative 5 squared minus 4 times 3 over 2 times 3. And when we simplify that, negative 5 is positive 5. Negative 5 squared is just 25. And then negative 4 times 3 is negative 12. Times 3 is negative 36. And then 2 times 3 is 6. So we end up with 5 plus or minus 25 minus 36 over 6. Well, what we should notice is when we combine these, we end up with negative 11. Well, going back to our idea of a discriminant, we know that if there is a negative under the radical, there are no roots. So in this case, we would just say there are no roots, or we'd say no solutions. So how do we know that there are no roots? If we take this equation and put it into Desmos, it looks like this. Well, we can see that it still forms a parabola, just like all the others do, right? That U shape. But notice it's above the x-axis and it never comes down and touches. So there are no roots there. Okay, just a reminder, you need to simplify under the radical all the time. So let's say you end up with square root of 12 under the square root symbol. You always need to simplify it as much as possible. And the way you do that is you're going to try to find the greatest square factor. So for instance, what we think about the factors of 12, and we recognize that the factors are 1, 2, 3, 4, 6, and 12. And we want to pick out which ones are perfect squares. Well, we know that 1 and 4 are perfect squares, but we only want the biggest one, so 4 is the biggest perfect square. So that's really 4 times 3. So we could take the square root of 4. The square root of 4 is 2. So this becomes 2, and then we leave whatever's left under the square root, which is 3. So this becomes 2 square root of 3. Simplifying fractions, remember once you're done and you get your answer, make sure that you simplify the fractions as much as possible. So let's say I get 4 plus or minus 2 times the square root of 3 over 2. If this value in the denominator goes into both evenly, then you need to go ahead and divide it. If it only goes into one, then you leave it, because it has to go into both. So 4 divided by 2 is 2, and 2 square root of 3 divided by 2 is just square root of 3. So we end up with 2 plus or minus the square root of 3. There's a video here now that you can watch that shows you how to check your roots for quadratic equations using Desmos. So go ahead and watch that video. Let's talk now about how we can use Desmos to check the roots of a quadratic equation. So first of all, I'm going to go to desmos.com, and then I'm going to go to where it says Graphing Calculator. And if you notice, it should take you to a page that looks like this, where it'll have the graph on this side. We just need to enter the equation over here on the left. So let's go ahead and do that. So let's say it's y equals 2x squared plus 5x minus 2. Well, as we can see, we have our graph that pops up here. And there's two places where it crosses the x-axis. That represents the roots. So if I click on it, I'm going to find the x-coordinate, which is right here. And I can see that the root for this one on this side is negative 2.851. And if I go to the other side, the root on this side is 0.351. So no matter which equation I type in, so I can type in y equals x squared. There's my second one. I can find where it touches the x-axis right here. And if I click on it, it will give me the root, which is the x-coordinate of that point. So this is how you would use Desmos to check the roots for a given quadratic. Let's take a look now at the Finding Roots by the Quadratic Formula Part 1 assignment. The assignment begins with the learning goals and success criteria. If we scroll down, we can see the questions. So this first one says, what are the roots of the equation? X squared minus 4x minus 60 is equal to 0. Well, we would plug that into our quadratic formula, which is negative b, so that would be negative 4, plus or minus the square root of b squared, so that's negative 4 squared, minus 4ac, so that's minus 4 times 1 times negative 60, all over 2a, which is 2 times 1. And then you would just go ahead and simplify that. And when we simplify everything, we should end up with x equals negative 6 and positive 10, which is this one here. So you'll continue to do that for each of these. Now some of them don't exactly come out evenly, and they're left in this form. That's okay. Just check your work and make sure that you did everything correctly. And if you end up with something like this, that's fine. So go ahead and continue to answer the questions all the way until you get to the end. When you get to the end, go ahead and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.